All right, concurrency of medians theorem. Medians are the centroid is 2/3 of the way from the vertex to the midpoint of the opposite side. Okay, that's the relationship. So you see all these relationships here. We see this point CE is 2/3 of the length of EG, or EC is 2/3 of EG. And DC, right here, this value right here, is 2/3 as long as the whole thing. Okay, so what that means is if you know a centroid length, if you know the length of a median, you can find the lengths of the other two segments. If you know one of the segments, then you can find the length of the median, or you can find the length of the other segment. It's all about setting up the things in the correct proportions. Here's what I mean. So I'm just going to limit it to looking at a single centroid. If C is the centroid, the sides CG, CE, and EG, or GE, are in the same proportion, 1 to 2 to 3. So it's like this one is the 1, this is the 2, and altogether is 3. Okay? So my advice to you is to find this little piece. Find that little piece. If you don't know it already, then you can find the other big piece, the other pieces. Okay? So if you know the little piece, you can multiply it by 2 to find the piece to the vertex. You can multiply it by 3 to find the whole thing. Okay? So the question here says find ZU if RU is 5.1. So we're given the RU. This is the big piece, right? Okay? And we're trying to find ZU. So this is like the 1 and this is the 3. So to go from the big piece to the little piece, we have to divide by 3. Okay? So 5.1 divided by 3 is 1.7. What that means is this little piece here is 1.7, and this piece here would be 3.4. It would be 2 times 1.7, and the whole thing is 5.1. So you can see that I would just divide by 3 to find my piece, and that's what ZU is. Okay? It's important to see that if you find one of them, you actually can find both of them. The next one says find MJ if TM is 6. So TM here is 6. Okay? Now, this piece is twice as long as this one. So TM divided by 2 would be 3. So MJ is 3, TM is 6. There we go. Okay? It's just proportions, guys. Okay. Find IL if CL equals 9. Okay. So I'm going to write this. This is 9. Okay. That means that CI would be 18, 2 times that, and C and IL, the whole thing, would be 3 times that, or 27. Okay? And then find EJ if QE equals 3. Okay? Now this is a little bit trickier because QE equals 3 means I need to divide by 2. So that would actually be 1.5. Okay? So EJ would be 1.5 if QE is equal to 3. So every single time here, I'm just looking at a proportion it's a 1, 2, 3 proportion. Okay? The small piece is 1, the big piece is 2, and the entire median is the 3. Last but not least, our concept summary. Knowing which one is which. If you have a perpendicular bisector, angle bisector, median, and altitude, you need to know which one center goes with which. Now the two that get confused very easily are perpendicular bisectors and altitudes. The difference is you see a perpendicular bisector, it cuts the triangle in half. It cuts the segments in half. You see an altitude, it goes through the vertex. So I'm looking at these two here. They both have that perpendicular, right? So we have a perpendicular line, perpendicular, perpendicular. So we have all these right angles. Well, and the bottom one, that's perpendicular bisectors. Okay? Because each one of these sides is congruent. See, this is the midpoint. That's our midpoint. That's a midpoint. That's a midpoint. Okay? These are out. The top one is altitudes because it's perpendicular, but you'll notice that it goes through the vertex. Okay? Therefore, we have here, this is our point here is the circumcenter. That's our concurrent point. And our point on the top one is our orthocenter. Okay? The next one, these are tricky because we have to make sure that we're identifying what's actually being congruent here. Okay? So we're looking at these, we see a bunch of sides that are congruent. These are called midpoints here. Now over here we see a bunch of angles that are congruent. Do you see those angles that are congruent? If angles are congruent, that means that each one of these lines is a bisector. So this is an angle bisector. That forms this one. And up top, this goes from the vertex to the midpoint, so that's formed by medians. Okay? So it's very important that you're able to identify from the picture, is it an altitude, a perpendicular bisector, a median, or an angle bisector. And if you just look at it, what each one is required to do, then you can tell. Our point here would be centroid. And our point here would be the end center. Okay?